another video just practicing area of regular polygons. I'm going to again use that formula 1/2 apothem times perimeter on number 2. And then 3 and 4, I'll show you using just the area of the triangle. Okay, like I said, I personally kind of like the formula more. It's totally up to you. Either way, you're going to get the same answer. Okay, in this one, we want to find the area. This is an equilateral triangle. It should say that, sorry. Equilateral triangle. Okay, so I'm going to use, because it's a regular polygon, all the sides are the same, I'm going to use this formula. So we need the apothem and we need the perimeter. So my apothem is this guy. Perimeter, I'm going to need to find the length of one of these sides. So again, I can kind of see I just formed a right triangle. So if I could find A and if I could find X, that's going to give me enough information to find the apothem and perimeter. So I'm going to, again, always start with that central angle formula. So we're doing 360 divided by 3, which equals 120. Now, the 120, I'm actually going to draw another triangle in here. The 120 is this whole thing. So this whole angle is 120, but I'm cutting it in half so that I can just deal with the right triangle and use SOHCAHTOA. So this angle right here is 60 degrees. So we are going to use SOHCAHTOA to find both A and X. I'm going to start with A. So again, here is my reference angle. So here's my opposite, adjacent, hypotenuse. So I'm going to find A first. So I'm going to do A and H, which is cosine. So we're going to do cosine of 60 degrees is adjacent over hypotenuse. And I'm also going to find X using sine, opposite hypotenuse. So we're going to do sine of 60 equals X over 5. So I'm going to multiply by 5. So A is equal to 5 times cosine of 60. So 5 cosine 60 is 2.5. And then we're going to do multiply by 5 here as well. So 5 times sine of 60 is 4.33 for X. Okay, so my apothem we found is 2.5. My perimeter, okay, so X we just found is 4.33. So we're going to do 4.33 times 2 to get this whole side. And then I have 3 sides total for that. Sorry, 3 sides, not 6. Excuse me, getting ahead of myself here. Times 3 for the number of sides. So again, this was 4.33. So if I double it, so we're going to do 2 times 4.33. So that gives me this whole side is 8.66. And then I'm going to multiply by 3 to get our perimeter, 25.98. So then our formula for the area of this equilateral triangle is 1/2 the apothem times perimeter. And again, if you want to do 1/2 as 0.5, you sure can. Then I can just enter it all in at once. So 0.5 times 2.5 times 25.98, 32.48 if we round to 2 decimal places. And our unit was centimeters, so we got square centimeters for this area. Okay. Now, this one does not give me a picture, and they just say find the area of a regular nonagon that has a perimeter of 144. So, nonagon is 9 regular sides. I'm not going to attempt to draw it. I'm just going to draw one of the triangles. Okay, so I know I have 9 of these that make up this nonagon. So, and the perimeter is 144. So if we do 144 divided by 9, that gives me the length of one of the sides is 16. Okay, and then if I find the area of one of these triangles and then multiply by 9, that's going to give me the area of the whole nonagon. So we are going to find area of triangle, then multiply by 9. Okay, so I am going to do the same exact thing. So area of a triangle, right, is base times height divided by 2. We know the base is 16. We need the height, right? So again, I need to find the height. I'm going to use SOHCAHTOA to do that. So in order to use SOHCAHTOA, we need an angle. So our central angle is 360 divided by the number of sides. So 360 divided by 9 is 40. So again, this whole angle is 40 degrees. So I am just going to work with the right triangle and use 20 degrees. Okay, so now there's my opposite, adjacent, hypotenuse. So I'm going to use O and A. So sine of 20 equals opposite over adjacent. Okay, now in this one, I do have to get h out of that fraction first. So I've got h sine 20 equals 8. And then divide by sine 20 on both sides. So we have h equals 8 over sine 20. So 8 divided by sine of 20, 23.39. So area of a triangle, base was 16. The height we just found, 23.39. And then divide by 2. So we have 187.12, and then we're going to multiply this times 9 to get our nonagon. So we have 1,684.11. And again, this is the whole nonagon. Inches was our unit, so this is going to be square inches. Okay, last example. Janet is designing a garden around a gazebo that is a regular heptagon and an apothem of 6 feet. The garden will be a circle that extends 10 feet from the vertices of the heptagon. What is the area of the garden? Round to the nearest foot. Okay, so we have this heptagon, and we have a circle garden around it. I'm going to attempt to draw this, you guys. Okay, so we got 1, 2, 3, 4, 5, 6, 7. Not horrible, not good. All right, there we go. So keep in mind all these sides are supposed to be the same, and mine are obviously not, but this is why drawing the pictures with regular, especially once you get like above 6 sides, it gets a little tricky. Okay, so we want the area of the garden. So the area of the garden is the circle minus the heptagon. Because the garden is this circular space that goes around it. And sorry, I didn't draw this really extending 10 feet from the vertices. I'm going to draw a bigger circle here, you guys. Okay, so we have this circle around our heptagon gazebo, and it says the garden extends 10 feet from one of the vertices, so that's 10. Okay, so, and we're told that this heptagon has an apothem of 6 feet. So remember, the apothem is from the distance from the center to the midpoint of one of the sides. So that's the apothem, that is 6. Okay, so the other thing I'm going to need, you guys, is, actually, we have enough here to start moving on, but basically I'm going to start a step at a time. I'm going to find the area of the circle and the area of the heptagon and then subtract. Okay, I'm actually going to start with the heptagon. So remember, I can find the area of just one of this one triangle right here. And then I can multiply by 7 because there are 7 sides. So I'm going to find the area of just one of those triangles. So I'm going to just kind of take this part and blow it up. Okay. All right, so we are going to find the area, I'm just going to call that x. Okay, so I need base times height, and then I'm going to multiply by 7. So I need the angle. So central angle is 360 divided by 7, which is 51.43. And again, remember, I'm dividing that by 2 to get just the one in the right triangle is 25.71. So that angle, 25.71 degrees. Okay, so we are going to find x. So here's my reference angle, here's opposite, adjacent, hypotenuse. So I'm going to do tan of 25.71 equals opposite over adjacent, so x over 6. So I multiply both sides by 6. So 6 times tan 25.71 is 2.89. All right, so we now know this x is 2.89. So we're going to multiply that by 2. So our area of a triangle, remember, is base times height divided by 2. We have the height is 6. We need the base. So I'm going to do 2.89 times 2. We get 5.78. So we're going to do... So I have my base is 5.78. Sorry, let me do this over here. Area of the triangle is 5.78 times our height of 6, and then divided by 2. $17.34. Okay, so now the heptagon is 7 of those triangles. So we're going to do 17.34 times 7. 121.38. All right, so there's our area of the heptagon. Now the area of the circle. All right, so we need the radius, right? So we need pi r squared. So the area of the radius is 10 plus this guy. So I'm going to use a different variable. We already used x. I'm going to call that guy y. So y is the hypotenuse of this triangle, right? So again, I can use SOHCAHTOA, so I'm going to put y over here. So that's hard to see. So I'm going to use adjacent and hypotenuse here. So I'm going to do cosine of 25.71 equals adjacent, which is 6, over the hypotenuse, which I don't know. So again, this one I got to get y out of the fraction. And then divide. So we're going to get 6 divided by cosine 25.71. 6.66. All right, so my radius is 6.66 plus 10, right? So this whole thing is my radius. So I've got pi, area equals pi times 16.66 squared. So we've got pi times 16.66 squared, which is 871.97. All right, so our last step is to do this subtraction. So I made my picture too big and I took up all my room here. So my area of the garden equals this one. This was my 871.97 minus the area of our heptagon, which was right here, 121.38. And that's our area of a garden. So we've got 750.59. And they want us to round to the nearest foot, so actually this would be 751 square feet. All right, that's it for those remaining examples, guys. Thanks for watching.